Hello friends, welcome to Multiverse Exams YouTube channel. Here we will be discussing on and we will be focusing on Gate ESE SSC JE all AE JE exams and engineering going students for semester exams. So in the previous class we discussed on types of system. One is open system, sorry, closed system, two isolated system, three open system. In the previous class we discussed on these two topics. Let us revise or we will get an overview. What happens in closed system is there will be no mass interaction but there is energy interaction. What happened in isolated system is neither there is mass interaction nor energy interaction. Okay, now moving further, in isolated system let us take a rigid container which is containing petrol plus air. And I am considering this petrol plus air as the system. Okay, somehow due to some interaction some transformation is taking place and we are getting a flue gas. Okay, means in isolated system there is only energy transformation but no any energy transfer. Okay, as I told, in isolated system there will be a insulation, no energy transformation take place. Okay, and this flue gas is the system as of now. So what I can conclude is In isolated system, there will be only energy transformation but no energy transfer. I can write it as in isolated system, energy transfer can't takes place, but energy transformation can take place. Okay, this is all about the isolated system. Now moving further to open system. What happens in open system is, in open system there will be both mass interaction and energy interaction also. So I can write it as open, it is the system where both mass interaction and heat energy interaction takes place. Okay, now I am taking a rigid container which is opened at both the ends. Okay, suppose mass is entering in here at the rate of 20 kg per second, and here the mass is living at the rate of 10 kg per second. And energy interaction is taking place. The energy interaction which is entering inside is at suppose 200 kilojoules per second, and the energy which is coming out is at 100 kg per second. Guys, here what happened to the mass? The mass is being stored inside the container. Me with respect to time means rate of change of mass with respect to time within the control volume, within the open system for the time being is 10 kg per second. And what happening to the energy? The energy also being stored inside the rigid container at the rate of 100 kg per second, means with respect to the time, means dE by dt is storing inside is 100 kg per second. Okay, means the mass is here changing, and the energy is also changing, and it is getting stored inside the rigid container. Okay, again, I'm taking an example. Here what happens is, suppose the mass is entering at 10 kg per second, and the mass which is coming out of the container is 20 kg per second. And similarly, the energy which is entering inside the container is 100 kg per kilojoule per second, and coming out is 200 kilojoule per second. Here what happening is, the mass which is decreasing, sorry, yes, the mass and the energy which is decreasing from the system is being is coming out of the system. So I can write the mass which is coming out of the system is here in minus 10 kg per second, and the energy which is coming out is minus 100 kg per second. Okay, here the negative sign means decrease in the mass and energy from the system. Now let's move forward. Suppose the mass which is entering at 20 kg per second is coming out of the system, or the rigid container is 20 kg per second, and the energy which is entering inside the system is 200 kilojoule per second, and the energy which is coming out of the system or the rigid container is 200 kilojoule per second. Means here what happening is the mass is neither being stored or utilized, or coming out is zero. Means the mass which is not being stored or utilized with respect to time is 0 kg per second, and the energy with respect to time which is not being stored or utilized is 0 kg per second. So I can conclude is that it is a case of steady flow open system. Okay, and these two cases are the case of these two cases are the case of unsteady flow of an open system. Okay, so I can write it as steady flow open system, where the rate of change of mass with respect to time is 0, and the rate of change of energy with respect to time is also 0. Where here we observed is that it is a case of unsteady flow. It's a case, wait a minute guys. Okay, it's a case of unsteady flow, where the mass with respect to time is not equal to 0, and the energy with respect to time is not equal to 0. Okay, Now moving further, here as I told you in the previous class that for closed system we can, the mass is being controlled, there is no mass interaction. So closed system is also known as control mass. Okay, what we call for open system, there will, here in open system the volume is being controlled, the volume is constant. As we observed in these three cases, the volume, this volume is being constant, this volume is constant. Okay, so I can call open system has a control volume. Okay, now an open system is said to be in steady flow open system if none of the properties change with respect to time at a particular state or location will be the correct meaning. As we observed here, none of the properties are changing here, where a 20 kg mass is entering and 20 kg mass is letting out, and the energy of 200 kilojoule per second is entering in and 200 kilojoule of energy is letting out. So the properties are not changing here. So it is a case of steady flow open system with a particular location. And I told you before, we can use open system as control volume also. Okay, so I can write it as again for steady flow open system, rate of change of mass with respect to time within the control volume is 0, and rate of change of energy with respect to time within the control volume is 0. Now I will be showing a diagrammatic representation of these three of types of system. Okay, Wait a minute, guys. In diagrammatic representation, here I will be writing types of system, and here mass interaction, and this is energy interaction. This is closed system, isolated system, and open system. What happens in closed system is there is no mass interaction but there is energy interaction. What happens in isolated system, there is no mass interaction but and there is also no energy interaction. What happens in open system, there is both mass interaction and energy interaction also. Okay, now let's move forward. Guys, I will be giving an overview of thermal power plant. Here it is a small concept based on the open system and the closed system. Okay, so now I will draw a diagram. This is an overview of thermal power plant. Guys, this is a boiler. I will be discussing later in briefly. The, there is a small concept hidden in this thermal power plant diagram. That's why I have to explain this. And this is the turbine, and this is the condenser. And this is the pump. The cycle goes like this. What happens from the pump is the subcooled liquid is coming from the pump, and uh, it goes to the boiler, and superheated vapor comes out. Which goes to the turbine, and the turbine blade moves, rotates, and from turbine the wet vapor comes out, and it goes to the condenser again. From condenser there will be a saturated liquid coming out. For the pump we will be providing a work input, and in the boiler we will be supplying heat, and when the superheated vapor goes to the turbine blades will be moving, and there will be a work output, and from turbine the wet vapor goes to the condenser, there will be some heat rejection. Okay, what we are here observing is the water or the superheated vapor is these all four pump, boiler, turbine, and condenser here are behaving as an open system. In these four, there is a mass interaction and also energy interaction. You can observe clearly here. And finally, here, what happens is what happens is the water which is circulating from pump, boiler, turbine, and condenser, there is no mass interaction or any energy interaction. So this water circuit is called as the closed system for this thermal power plant. Okay, so now pump, boiler, uh, turbine, condenser are the examples of open system, while here the water circuit of the thermal power plant is a closed system. Neglect the, in bracket we can write it as neglect water losses. There will be some losses of water, just neglect it. Okay, guys, again now your favorite topic, property, a new topic. What do you mean by property? Characteristic of the system to which a number can be assigned to a given instant of time, at any given instant of time. Okay, suppose now I am taking a rigid container which is filled with air, and I am considering this air have mass, volume, temperature, pressure, some thermal conductivity K, and viscosity also. Okay, we can tell that this air have some mass, 1 kg mass, 2 kg mass, 3 kg mass, 4 kg mass, and volume 1 meter cube, 2 meter cube, 3 meter cube, temperature 1 degree Celsius, 2 degree Celsius, 3 degree Celsius, pressure 1 bar, 2 bar, 3 bar, 4 bar, thermal conductivity watt per meter Kelvin, some number, and viscosity kg per meter per second, some number, assign it. Okay, means, as I told you the definition, characteristic of the system to which a number can be assigned. I can assign a number to these all conditions: to the mass, vapor, volume, temperature, pressure, thermal conductivity, and viscosity. For the air, there will be color, suppose this is a gas also, so or air or gas. This gas has some color, some taste, some smell. Can we assign any number to these three? No, we can't assign any number to these three. Okay, so what I am trying to tell is that this is not a property, and these six fundamentals are property. So I can write in the definition form as characteristic of system to which a number can be assigned at any given instant of time. Okay, now moving further, types of property. In types of property, there are two types of property. One is extensive property, and second one is intensive property. For understanding these two, now I am taking a container. In this container, there is some mass, volume, temperature, pressure, thermal conductivity K, and viscosity. What I am trying to tell is, again now I am taking now I am dividing this container in some parts. I am dividing into two parts, three parts suppose. I am dividing this container in two halves. and the second half again I am dividing into another half. Okay, suppose uh, in this container now I am dividing the what happened to the mass is first when I am dividing in two halves the mass become half. The volume also become half. What happens to the temperature? Here also it will be here also it will be 25 degrees Celsius, and here also it will be some 20. For example, I am taking 25 degrees Celsius. Here it will be also 25 degrees Celsius, and here it will be also 25 degrees Celsius only. So what I can conclude is the temperature will remain same. What happens to the pressure? The pressure also remains same. When here it will be a 2 bar, here it will be also 2 bar. Here it will be 4 bar, here it will be also 4 bar. So the pressure also remains same. What happened to the thermal conductivity? The thermal conductivity also remains same, and the viscosity will also remain same. Okay, now again I am dividing this bottom half into two halves. What happen again is this mass is divided again into 1 by 4, and the volume will be V by 4, and the temperature will remain same, pressure will remain same, thermal conductivity and viscosity will remain same. What happens in the third half will be mass will be m by 4, volume will be v by 4, temperature, pressure, thermal conductivity and viscosity and thermal conductivity will be remaining same. What we have observed is that this mass and volume are depending on the size of the system. Okay, so this mass and volume are the extensive property. Here the definition of the extensive property will be it is the property which depend on the size of the system, and the remaining these temperature, pressure and thermal conductivity and viscosity are not depending on the size of the system. The temperature is remaining same whole in the uh, three parts of the system. So these four are the intensive properties. So I can write the definition of the intensive property as is known as extensive property it is the property which is independent independent of the size of the dependent on, it will be the correct meaning, independent on the size of the system is known as intensive properties. Okay. um, as I told you guys, this depend on the extensive property depend on the size of the system, and the intensive property depend on the independent on the of the size of the system, or does not depend on the size of the system. Okay, now moving further. Extensive property and intensive property. Okay, as I told you that mass and volume are extensive property, and temperature, pressure, thermal conductivity K, and viscosity is the intensive property. There are some more properties which are extensive property and intensive property. Okay, kinetic energy is the extensive property, potential energy is the extensive property, and energy is the extensive property. Internal energy, enthalpy, and entropy is the extensive property. For the time being, just understand, I will be explaining you further what is internal energy, enthalpy, and the entropy. I'll be discussing in detail these three. Okay, and there are some more, like electric charge, and magnetization. Here, electric charge means Q is equal to Ne. N is the number of electrons, and E is the charge on an electron. Okay, number. There are some numbers. And magnetization, as we know, depends on the number of dipoles. Okay, now coming to intensive property, velocity. As I told you that suppose this container is moving with some velocity, or suppose this container. Suppose this container is moving with velocity c v. This half of the system this half of the system is having the same velocity, and this half of the system is having the same velocity, and this half of the system is also having the same velocity. What I am trying to say is that the velocity is an intensive property. Okay. And specific heat, small c. What do you mean by specific? Specific means any property divided upon mass. Okay. Specific. This specific property can be, we can write it as the specific volume, specific pressure, or specific volume also. This is specific heat. Okay. I can write specific and there is one also, chemical potential. Guys, what is the definition of density? Mass upon volume. In the above case, we have seen that mass in this case, the mass is m by 2 and v by 2. What comes after cancellation is m by v. Again, in this second case, if we observe, mass density is equal to m by 4 upon v by 4. What comes after cancellation is upon v. And again in this is the second case. Again we observe in third case also, m by 4 upon v by 4 is m by v. What here is, in the first case the density is m by v. In the second case the density is m by v. In the third case also the density is m by v. So what I can tell is that density is an intensive property. Okay. Again, uh, specific internal energy. As I told you that specific means any property upon mass. Okay, means specific internal energy means internal energy upon mass. And there is again one specific enthalpy. I will be representing with small h, capital H upon small m. Again, specific entropy. I will be representing with small s, capital S upon capital M. These are only the specific terms which we use in basic thermodynamics. Or okay, so I can write it in a definition form like ratio, guys, again one word, this is a extensive property, internal energy, and this mass is also intensive extensive property. This enthalpy is also an extensive property, and this mass, as we know, it is an extensive property. And this entropy is also an extensive property, and this mass is also an extensive property. When these when I am dividing these two extensive property, I am getting one intensive property. When I am dividing enthalpy upon mass, I am getting specific enthalpy, which is an intensive property. When I am dividing entropy and mass, I am getting specific entropy, which is an intensive property. So I can conclude is that ratio of two extensive properties is an intensive properties. Okay, as I told again that specific properties are defined as extensive properties per unit mass. Okay, specific properties such as specific volume, specific, internal energy, specific enthalpy, specific entropy, are intensive properties. Basically, all specific properties are intensive properties. Here, add it again one point. Basically, all specific properties are intensive property.